Right. Hello, everyone. This is UCAN Academy, and today we're going to talk about roots or solutions of a linear equation in one variable. So you can see here four examples that I have prepared, and what we're going to do is, as what you can see, we are already given a value for our variable. So in this case, we have given with x and the value of m in number 4. And what we're going to do here is we're going to verify if these given set of values, or shall we say, we can call them replacement values, as a solution or root of our linear equations. So let me start with the first example. X minus 4 equals negative 2. And we will verify if the given value of x is indeed the solution of that equation. So the process that we're going to use is very simple. We're going to use the substitution method. What will happen here is this replacement value of x will be substituted to the value of x in our equation, so that this would become 2 minus 4 equals negative 2, taking into account that the suggested value or the replacement value for x is equal to 2. Now, all that's left for us to do is to check if the answer on the left side of the equation is equal to the right side of the equation. And if we're going to perform the operation, 2 minus 4 is indeed negative 2, and that is equal to the right side of the equation, which is negative 2. And with that, we have proven that the left side is equal to the right side. And so we can say that 2 is a solution or a root of our linear equation. That's how simple it is. Now, let's try another example here. Let's try to see about number 2. So let me label this first as number 1. Let's do number 2. Number 2 is x over 3 equal to 7. And our replacement value for x is equal to 21. So again, repeat the process. This is going to be 21 over 3 by virtue of substitution method. So that is equal to 7. And if we're going to divide or simplify 21 over 3, that is indeed 7. And that makes our equation true, or the equality statement, if you will, it's true. So what is our realization on this one? It means that 21 is a root or a solution of our linear equation. So for number 1 and number 2, I hope everything is very clear. Let me now erase this part so that we could accommodate the other examples. We will now start or continue with example number 3. So let's try number 3. And number 3 right here is 5x minus 3 equals 2x plus 2. And the suggested replacement value is x equals 5 over 3. So let's again use the process of substitution. Now, you will notice that on the left side of the equation has a variable x, and at the same time, the right side also contains the variable x. So what will happen here is, for both variables that we can see on the left and on the right side of the equation, we are going to replace that with our replacement value. So what will happen here is, I'm going to copy 5. 5x means 5 times x, and I'm going to replace x with 5 over 3. Continue with minus 3 and our equal sign. This will be 2 And I'm going to multiply that with my replacement value 5 over 3 and continue with plus 2. And after that, since I'm done with my substitution, now it's time for me to perform this operation. So 5 times 5 over 3 becomes 25 over 3, okay, minus 3 equals 2 times 5 over 3 becomes 10 over 3 plus 2. Now, I'm out to prove if the left side after performing the operation is equal to the right side. So what is 25 over 3 minus 3? So what I'm going to do here is make it as a similar fraction. So what will happen here, this will be 25 over 3. And what I want to do here is I will make 3 as another number, as a fraction, in fact, which has a denominator of 3. And what should be the numerator so that simplifying that it's still equal to 3? Okay, so that is actually 9 because 9 over 3 is equal to 3. Next, I have 10 thirds here. I'll do the same for 2. I'm going to make it as a fraction, and I'm thinking of a numerator that will make the fraction still equal to 2. So I think you know the answer for that, and that is 6. Now perform the operation. We have similar fractions on both sides of the equation. You have 25 minus 3 minus 25 over 3 minus 9 over 3. This becomes, okay, 16 over 3. And it should be equal to the right side of the equation, which is also 16 over 3. So that means the equality statement is true. We can say, or we could generalize, or we could conclude that 5/3 is the solution or the root of our linear equation. All right, we're now down to the last item. Let's see, and I'm going to do some erasing once again. Okay, I hope you've taken note of the process. You may want to go back to the process if you want. And so we continue with number 4. Okay, so number 4 right here. Okay, just little adjustment here. So number 4 becomes 2 times quantity m minus 1 equals 8. And replacement value m is equal to 5. Now, you may have some options right here. First option is you may want to distribute this value outside the parentheses, okay? And we are allowed to do that because we know that there's this property which is called distributive property of multiplication. And after that, then we could do the substitution. Or you could do the substitution first and perform the operations before you do the multiplication. Okay, so I'll take that route and let's see if we have a true equality statement. So what I'm going to do first is I'll copy 2. I'm going to replace the variable m with 5 because it's my replacement value, and that's going to be minus 1 equals 8. So what happens is, since we're still following the PEMDAS rule, we're going to do first the operation inside the parentheses. So this will be 2 times 5 minus 1, which is 4, and that is equal to 8. And from here, we can clearly see that the left side of the equation is 8 equal to the right side, which is 8, which means that 5 is a root or a solution of our linear equation in one variable. Okay, so that's all for now for this video on verifying whether a given replacement value for the variable is a solution or is a root of the linear equation in one variable. And take note, a linear equation in one variable has only one root or solution. So once we have verified that the given value is a solution, then that's it. We're done. Okay? So thank you once again for listening. I hope you find this video very helpful.